this lesson is about solving quadratic equations by graphing. So we're going to learn several ways to solve a quadratic equation, and this is the first way. We've already been solving or graphing quadratic equations, and so now we're just going to pick out the particular part that solves it. Now, we've already talked about this. The solution is the x-intercept, which is also sometimes called the roots or the zeros. All of those refer to the same thing. They refer to where the parabola crosses the x-axis. And so we've already talked about that, and hopefully you remember it. So if you look at these three here that we have before us, there are two solutions on the first one because it crosses the x-axis in two places. And so we could say that this solution would be -3 and +2. And so we've talked about using the solution set. So that's what it would be for this one. The second one only has one solution because it just goes up, touches the x-axis, and turns around and goes back. So this one, the solution would just be 3. No other number there. And then the last one never touches the x-axis. All of it is above the x-axis because the vertex is above it, and then it's going up, so it never makes it. So this one is a no solution, which you could also show by just drawing what's called the empty set, and it's two braces with nothing inside. So to solve a quadratic equation means that you're finding the x-intercepts. This is also the point where the y value is 0. So that stuff is down here at the bottom, and it is really important. So y is 0 on the x-axis. All right, so in order to solve a quadratic equation, you're going to graph it and then figure out where it crosses the x-axis and write the solution on the space at the bottom. If there are no solutions, then we're just going to put the no solution. Now, it is important before you graph these that they are in standard form. So they have to be like this: y equals, and then x squared plus whatever x plus whatever at the end. So if they're not in standard form, you do have to rearrange them in order for that to work. Now, just like we did before, we can use our graphing calculator to help us graph these. So what I'm going to do is I'm going to go to y equals, clear out anything that's there, and type in x squared plus 14x plus 48. And then I'm going to hit graph. So this is what it should look like when I get finished. So I'm going to go to my table, and I'm going to find that vertex. So remember when looking at the graph that the vertex happens way over to the left. So that means that my x needs to be negative. So I'm going to look at some negative numbers. And right there you see there is the vertex at -7, -1, because the two numbers on the other side are -8, 0 and -6, 0. So that is where it makes the turnaround. So I'm going to start at -7, 1, 2, 3, 4, 5, 6, 7, -1. So that means I go left 7, down 1. And then I've got -8, 0. And -6, 0. And then I have -9, 3. So I'm going to go over to -9 and up 1, 2, 3. And -5, 3 means I'm just going to go to -5 and up 1, 2, 3. So there's my parabola. Go ahead and just sketch that graph. Remember, it doesn't have to be perfect. Mine definitely is not. And so what I'm looking for is where does it cross the x-axis? Well, it crosses the x-axis right here. So there's two spots right there. So my solution is the x value, because the y's there are 0. So I've got -8 and -6. So that's my solution, the x value where it crosses the x-axis. Okay, let's do another one. Just go back to y equals, clear this out. And you can do this without the calculator. It just takes some more time because you have to do some trial and error and figure out these by hand. So we're not going to make you do that. I'd like to look at the graph so I know kind of what I'm in for. So I can see here that this is going to be a big parabola. I also know from looking at it that my vertex is a negative number because of the parabola being over to the left side of my screen. So I'm going to go look at some negative numbers here. And it looks like maybe the vertex is not a whole number. So we did have some like that the other day. If that happens, you can find the axis of symmetry, negative b over 2a, like that. And that does tell you that it's going to be negative 7 over 2, which is negative 3.5. So between negative 3 and negative 4 is where our vertex is going to be. So I'm actually just going to use 6 other points and not plot the vertex. I'm not trying to find the vertex. I'm trying to find the x-intercepts. So I can't use negative 20. Did I type this in right? Because this is a very strange x squared. Okay. So I can't use negative 20 unless I change my scale. So if I count by 2's on the y-axis instead of 1's, I could do this. So if that's the case, I'm going to go left 4, 1, 2, 3, 4, and then down to 10. I'm so sorry. And let 3 and also down to 10. So that means that the vertex is going to be under that a little bit, like right here. And then I've got negative 5 and negative 18 and negative 2 and negative 18. So that would be on negative 9. And you can see that I'm going to have to start heading back the other way. I'm going to take this little vertex off because that's probably not in the right place. So I'm going to have to get to 0. So I'm going to have to keep going. So negative 6, and it goes to negative 14. So that would be at like negative 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. And that's also, if I look on here at negative 1 as well. So this parabola, I'm going to end up with a lot of points. Then I have 0, negative 8, which would be negative 4. 1, 2, 3, 4, because remember I'm counting by 2's. And then I also have that same negative 8 over with negative 7. So that would be here. And then the one before that is negative 8, 0. And so then that means that 1 should also be with a 0, and it is. So we had to do a lot of points on this parabola in order to get it looking like I wanted it to, and to get up to the x-axis. All right, so that means that my solutions are negative 8. Oh, whoops, I looked at the wrong one. Not negative 8. I have to look at where y is 0, so that would, oh, it was negative 8. And 1 is the other one. And notice my squiggly lines look a little bit like garbage. So this one is kind of a trickier one because the vertex wasn't graphed, and it was kind of a little bit too big. If you look at your graph, though, on your calculator, you wouldn't have had to have graphed all this to find those two things. So you can see on there that it crosses the x-axis at negative 8 on the left and 1 on the right. So you can use your calculator to do this without even graphing it on the paper. All right, so that's that. And we've got 4 more. So I'm going to do a couple of these in each section and then leave some to do in class. So let's do, I'm going to do y equals x squared minus 4x plus 3. And the next one after that, x squared plus 6x plus 10. All right, so let's zoom this in so we can do this. X squared minus 4x plus 3. And when you graph it, you can see that it's going to be kind of over to the right side of the graph this time. So that means that I'm going to have a positive number for my x, for my vertex, and it's right here. You can see that because it turns around and does another 0 right after that. So I'm just going to graph those 5 numbers that are there on the screen. So I've got 0, 3. So that means you don't go left or right, you just go up 3. 1, 0. So that means you go right 1, but you do not go up. 2, negative 1. And 3, 0. And then 4, 3. So that's a little kind of baby parabola. So you can see here that our solution is 1, because it crosses here at 1. And the other answer is 3, because it crosses there at 3. Oh, that's a real fancy one. Let's change that. That doesn't quite look right. Okay. All right, and then I'll do one more. So we've got x squared plus 6x plus 10. So we're going to go in here, clear that out. X squared plus 6x. Whoops, wrong button. Oh my. Plus 10. I'm going to hit graph so I know it's going to be over on the left side. So I'm going to go to shift table or second table, and then I know I need a negative x. My vertex is on the negative side, and so right there it is, negative 3, 1, because you can see the numbers start back again around it. So I'm going to have negative 3, 1, so I'm going to left 3, 1, 2, 3, up 1. And then I've got negative 4, 2, so I'm going to go left 2, left 4, up 2. And negative 5, 5. So I'm going to go left 5, 1, 2, 3, 4, 5, up 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then on the other side, I had negative 2, 2, so left 2, up 2, and negative 1, 5. Now, this one, I'm so glad I picked this one. This one doesn't cross the x-axis. So this one has no solution. No solution at all. I was hoping that there would be one with one solution. Let me just check them real quick, and if there is, I'll go ahead and do another one. So x squared plus 18x. I don't think there is one with just one solution. Oh, nope, that one is. Okay, so we'll go ahead and do this one since I already have it in anyway, and I'll just do that last one later. So we can see, again, our vertex is negative. And you can see on here, on the screen, that, oh, no, I don't want to do that, that it's just going to touch that x-axis and then turn around and go back. So negative. So right there it is, negative 9, 0 is where it's going to touch and turn around. So the vertex and the solution are the same. So I'm going to go over here to negative 9, 0 and put a point. And then I can't really do a lot of other points. I can do 10, 1, and I can do, or negative 10, 1 and negative 8, 1. And then I can do negative 7, 1, 2, 3, 4. If I need to, I can go ahead and do negative 6, 9. So that's 1, 2, 3, 4, 5, 6 left. Up 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is all I can get on there because my graph runs out. But I'm just going to kind of make it look symmetric like that. Okay, so that's what you should do if you run out of graph, is just kind of do the best you can. And so this only has the one solution of -9 because that's the only place that it touches the x-axis, is right there at -9. All right, we will do more of these in class.